Alright, so as promised, for our last online module of the semester, we're going to have a look at a focused analysis for the aircraft's spin, and in particular flight test techniques, instrumentation and sensors with regards to this very specific and highly complex aircraft maneuver. So most of what I'm going to talk through in this online module is going to be based on a article that I wrote for Progress in Aerospace Sciences in 2018. Again, taking the opportunity to publicize my own research, but it's basically a review article on the development of flight test instrumentation and equipment with particular regards to the aircraft's spin. It's quite historical in its approach, goes through the history of the flight tests of this particular maneuver, how instrumentation was developed up to the present day. So as I say, it's a review article. If you're interested and want to read more about what I'm talking about today, then go and look it up. There's 73 references in this particular paper, and all of the figures and quotes that I'm going to reference in this online module are referenced in this article if you want to go and look those up. So before we get into talking about flight testing and instrumentation, we just need to introduce the concept of the spin and what the stall spin is, what causes it, and what are the main characteristics of it. So the stall spin is defined as an auto-rotating descent of a fully stalled aircraft. So this descent is in a helical pattern about the vertical axis. And it's caused when the critical angle of attack of an aircraft's wing is exceeded. This obviously leads to flow separation on the upper surface of the wings, and hence a reduction in lift, right? So that's the stall. You should all be familiar with the concept of the stall. But from there will be an inevitable imbalance of wing loading, which causes one wing to fully stall before the other, and then the one wing that's fully stalled will drop before the other wing, and this will initiate the spin in this downward helical pattern. So there are three main stages of the spin maneuver. The first stage is the incipient stage, and this is where the aircraft transitions from straight and level flight, although stalled, into this auto-rotating vertical descent, into the spin, right? Then, as the spin develops, the spin frequency and spin radius stabilize and become constant. And then the recovery stage is where the pilot takes corrective action to regain control of the aircraft and recover from the spin. So today what we're talking about, we're mainly interested in the developed stage of the spin, so that we can put some numbers on the spin frequency, which we're going to define as the number of rotations per second, the spin radius, which we're going to define as the distance between the aircraft's center of gravity and the spin axis, the vertical axis, right? And also try to characterize the angle of attack during the spin as well, because as we say, the aircraft is fully stalled throughout the spin. So obviously the spin is not to be confused with a downward spiral, as we've discussed in the past. During the spin, an aircraft is fully stalled and has a very tight radius of rotation, which we'll have a look at in a moment. But generally, the characteristics of a spin, they coincide, right? So you might have heard the term flat spin. This is where an aircraft has close to 90-degree angle of attack, right? So pretty much vertical descent, and in this case, in a flat spin, an aircraft will have a faster frequency and a tighter radius. So a lot of these characteristics are interlinked, frequency, radius and angle of attack, depending on the type of spin that it is. So here you can see a diagram of what the spin looks like. You can see in the top left hand side of this figure here, you can see the aircraft stalling and then entering the spin in the incipient stage. Then after a couple of rotations, the spin is fully developed and the frequency and radius have become constant, and then after a few more rotations the pilot takes control of the aircraft and recovers from the spin in the recovery stage. So that just gives you some idea of what the spin looks like, the profile of the spin, how the spin axis is defined, right? It's the vertical axis about where the aircraft is spinning. Its center of gravity position is rotating about the spin axis. And it also gives you some idea of how small the spin radius can be. You can see here in this particular diagram that the spin radius is no more than the aircraft's length itself. So why are we looking at the spin in so much detail? Why is this particular aerodynamic feature important? Well, from the pilot's perspective, the spin is a very dangerous scenario to find himself in, particularly at low altitude, because as you've seen in the previous diagram, sufficient altitude is required to be able to recover effectively, because essentially the pilot needs to recover the angle of attack. So generally pilots these days learn to avoid the stall rather than gain experience of how to recover from the spin. So as I say, it's a very dangerous scenario to find oneself in, and pilots of certain categories of aircraft fear the spin, as it's generally attributed to a very high proportion of aircraft accidents, particularly in general aviation. So aircraft are generally designed so that recovery from a spin is possible in certain categories of aircraft anyway, such as tactical training, aerobatic type aircraft, and for some pilot licenses, pilots must be able to show that they are able to effectively recover from a spin. So how is a spin performed and recovered from? So you're going to see a video of this in a moment, but I'm just going to kind of talk through the various stages first. The first step, of course, is to check that you're in a suitable piece of airspace to perform the spin, that there's no other aircraft around, particularly looking below, because obviously we're going to fall out the sky when we do the spin maneuver. So the first thing is to check the surroundings to make sure that it's safe. Then the pilot can decelerate the aircraft by reducing the power and gradually pitch the nose of the aircraft further and further up in order to maintain altitude. At a certain point, obviously, the stall will start to be apparent to the pilot. The pilot will start to feel the natural buffeting through the stick, and once the aircraft is fully stalled, the aircraft is hopefully fitted with a stall warning horn, or the pilot can recognize the speed as being below the published stall speed, right? At this point, the pilot will make a full rudder input either to the left or to the right to initiate the spin. So this is mimicking that wing drop, right? So that it's mimicking the fact that one wing fully stalls before the other, and we have this imbalance of loading on one wing or the other, and this will initiate the spin. The pilot will continue to hold the stick fully back to keep the aircraft fully stalled, and with the rudder pedal in the particular direction that they choose fully pushed in that direction. So that will enter the aircraft into the incipient stage of the spin. The spin will stabilize after a couple of rotations into the developed stage, and then to recover, there are several techniques depending on what pilot manual you read, but the typical and generally accepted technique is to reduce the power to idle in case that you're in what's called a power on spin, then to centralize the ailerons if you haven't done that already, apply full opposite rudder to oppose the yawing, and then to gradually push the stick forwards to reduce the angle of attack. And hopefully the rudder correction will stop the spinning. Pushing the stick forwards and hence using the elevators to reduce the angle of attack will enter the aircraft into a dive in order to regain sufficient airspeed to recover from the spin. So now you're going to have a look at a video of myself and an old colleague, Professor Nick Lawson, in the right hand seat here, in a Scottish Aviation Bulldog, former RAF trainer, performing a spin for some research that we were doing at the time.